Let's go through this continuation of the news vendor problem where I try to explain expected loss and expected profit for the retailer and expected profit for the supply chain. While we review some topics that we have already discussed, we will explain new concepts and then we set the stage to talk about more concepts which are mainly about coordination and collaboration in supply chain. We have a product and we have average and standard deviation of demand for a specific period. The retailer sales price is $10 per unit. Retailer cost to purchase this product from a manufacturer or a supplier is $5 per unit. Salvage value of this product at the end of the period is 0. The manufacturer cost is $1 per unit, but that is not our concern for the time being. These data is given. Now, during this period, if the retailer does not have the product, but demand is available, then there is a underage cost, which is simply the difference between sales price and purchasing cost, underage cost, CU, and that is equal to 10 minus 5, which is $5. If the retailer has the product, but the demand is not there, then we have a overage cost, and that is simply the purchase price minus the salvage value of that product, and that is equal to $5. Underage cost $5 if demand is there but we do not have the product. Overage cost is $5 if we do have the product and demand is not there. In the context of the news vendor problem, the service level is defined as underage cost divided by all costs. And all costs here are underage cost and overage cost. The cycle service level, optimal cycle service level, or simply service level, optimal service level, is equal to CU divided by CU plus CO, and that is 5 divided by 10, which is equal to 50%. Now we know the service level, and what we need is to identify safety stock under this overage and underage cost. If we have probability and want to compute safety stock or reorder point, we have several choices. We can type equal to norm inverse, and the probability is 50%. Average demand is 100. Standard deviation is 300. Our reorder point is 1000. We can also compute safety stock by norm standard inverse, and then we enter 0.5, and then the formula tells us you need to go 0 standard deviation to the right of the average. Your safety stock in this specific case is 0. We need to also know how to use normal table. We go inside normal table, we look for 0.5, it is here. And then 0.5, we go horizontal, 0, vertical, 0. Therefore, the corresponding z value is 0. Because in this specific situation, we have the reorder point equal to the average demand. And in the safety stock of 0, maybe it is not easy to grasp things. Let me just change this retail sales price to 4. In that case, our service level goes up to 60% because our overage cost is 4, underage cost is 6. Now here, I have the formulas. Especially in this case, I'd like you to use norm standard inverse. I will explain it later. For table, we need to go to 0.6, 0.58, 0.59, 0.6. This one is closer. My z value is 0.25. It is not the exact value for this service level, but it is close enough. Whenever we don't have access to computer, we may just simply use normal table. Now if I go and change this one to 7, service level goes down to 0.3. That means we even do not order average demand. Why? Because in this situation, overage cost is quite larger than underage cost. And that leads to a reorder point of 843. And we need to go about half a standard deviation to the left. First, let's use table. 0.3 is not here because it starts from 0.5. So 0.3 should be somewhere here. 0.3. This one is closer. So that is negative 5 plus negative 2, which is negative 52. Let us go back to the original assumptions. We had 5 here. We had safety stock of 0. The order quantity that we place is equal to the average demand, and that is 1,000. Again, in this specific case, the quantity that we order is equal to the average demand. It could have been more than or less than average demand. No matter what they are, the rest of our computations remain valid in all cases. The demand has an average of 1,000, and we also have ordered 1,000. How much do we sell in long term after many periods? Demand has an average of 1,000 with the standard deviation of 300, and we have 1,000 units. What will happen if this process is repeated many times? Or if we do have 100 products with these characteristics, and for all of them we keep an inventory equal to the average. Can we sell average for all of them? And suppose they all have the same sales price, the same purchasing cost, and the same everything. Just to tell you that situation does not require one period to repeat itself several times. It could be a period which is applied to several products, which are different in nature. Let's go back to this problem. Under what circumstances our sale can be equal to average demand? In long term, when this process is repeated many times, how much should we have in each period to be able to sell average? Only if we have a very large inventory, we can sell average. Don't forget, if demand has an average of 1,000 with the standard deviation of 300, and if we do have 1,000 units, when demand is greater than 1,000, we cannot satisfy it. We can only satisfy 1,000. If demand is less than 1,000, we can satisfy it. the average of sales will be always less than average demand. Even if we do have more than 1,000, suppose if we do have one standard deviation more than 1,000, still our average sales would be less than the average demand, because the actual demand can go high and low. If we can satisfy all of them, then the average sales could be equal to average demand. However, because in some cases demand is more than what we can satisfy, the average sales is always less than average demand. And that is why we always have lost sales. Especially in this case, if we only have a quantity equal to the average, if the actual demand is less than average, and that is what we have, we can satisfy it. But if it is more than average, we cannot, because we do not have that much inventory. So again, over a large number of periods, average sales is always less than average demand. We always have lost sales. We are under stock by a number of units. To compute that number of units, we can use Z value. Now let's go and talk about the expected loss. Before we talk about that, let's understand the equation for loss function. We compute loss function and then multiply it by standard deviation of our demand to compute expected loss, lost sales or understock volume. Let's look at this formula. We can compute it in Excel or we can use tables. It looks a little bit strange, but let's go inside it. Norm standard distribution, Z and 1. Give me Z, I will give you a probability. It is the meaning of this statement. But we already have that probability. In order to avoid confusion, let me make some changes in the statement of the problem. Because right now, this is 50%, safety stock is 0, and then what we order is equal to the average demand. This may create some confusion. Let's make purchasing price of the retailer 4, and also let me assume that there is a salvage value for the product. Purchase price for the retailer is $4, sales price for the retailer is $10, salvage value is $2, and manufacturer cost to produce this product is $1. In this situation, service level is 0.75, Z of normal table associated with 0.75, norm, standard inverse, 0.75. And that is the Z value 674, and that is what we have. This tells us you go 0.674 standard deviation to the right in order to improve your service level from 50% to 75%. And then if you multiply it by standard deviation of demand, we get 202. That is our safety stock. If we add it to the demand, that would be the quantity we order. Now let's go to this norm S distribution. It says give me Z, I will give you a probability. But we have already found this Z based on the probability. We used this probability and we found this Z. Therefore, all it says, give me back this Z and I will give you back that probability. And what was that probability? It was service level. Type equal to norm dot S distribution, this Z, and if I enter 1 for cumulative, 0.75. Therefore, this part of this equation is just simply service level. 1 minus service level is here, and that is a risk. That part is equal to 1 minus this one, which is risk. And then it takes z and multiply by it, equal to, this is my z, and let's multiply it by it. That is the whole part here. I put a negative sign in front because it is negative. What the other part states? Norm, S, distribution, Z and 0. Let me explain what is the difference between norm S distribution Z and 0 and norm S distribution Z and 1. So if I go here, norm, standard, distribution, and I enter this, and I enter 1, and I get this probability. If I enter 0, what is it? It is the height. It is this height. If I enter 1, it will give me this probability. But if I enter 0, it will give me the height of the curve at that point. We are not responsible to prove it. We just understand what those pieces mean. And if we do this computation, we get 1492.1492. We can also go to our z is, in this case, 0.674, 0.67. This is 0.67, 1503. You can come here and enter 1503. And that is almost what I have got over there. It's not exact 1503 because 0.67, that is 0.674. So it is almost in the middle of these two, but I don't bother that. I just pick this one. It is a good approximation. So we can use Excel formula and we can use standard loss function table. In any case, we get here, that is expected loss. Now we want to compute expected sales. From what should I subtract my expected loss? From what I have ordered or from average demand? From average demand, because in the best case, I can sell average demand. If I subtract expected loss from average demand, I will get expected sales. Now I have expected sales. What is my expected leftover? This is my expected sales. What is my expected leftover? I had this much. I sold this much, so I should subtract it from what I had, and that would be my expected leftover. Now, I do have my expected sales, I do have my expected leftover, I do have my expected loss. What is fill rate? It is equal to expected sales divided by average demand. I just take expected sales, which is this one, and divide it by expected demand, which is average demand. And I get fill rate for this specific service level. Service level was 0.75. My fill rate is about 0.96. Expected revenue, the retailer. The retailer sells this much and sell it at this price. We get this one multiplied by this one. That is the revenue. And also any leftover, which is here, is returned for this price. So that is the total expected revenue of the retailer. But what is cost? The cost is indeed exact, not expected, because the retailer has bought this many units and has paid this much per unit. Therefore, to compute expected revenue, we multiply the expected sales by this one and expected leftover by this one. Our cost, we have paid $4 per unit, and we have bought this many units. And if we subtract these two from each other, that is profit for the retailer, expected profit for the retailer. There are many other ways, but one which I want you to follow. Let's look at the retailer. This is expected sales. The retailer has sold each unit for $10 and has bought each unit for $4. That would be multiplied by 10 minus 4. That is one part of the profit of the retailer. But there is one other item. The retailer has this much left over. We have bought it for $4, but we can return it back for $2. Therefore, this much should be subtracted from the other part. Because in this situation, we have got $2 while the price was $4, so this part is negative. And these are two different ways to compute retailer's profit. Manufacturer has sold this many units, and for each one has got this much money, while his cost was this much. So it is 4 minus 1, profit for each unit of product, multiplied by what the manufacturer or the supplier has sold to the retailer. But there is one other part. Whatever is left was returned back to the manufacturer or supplier at the salvage value of $2. We need to compute that revenue, the first revenue, the gap between sales price and manufacturing cost for the supplier or manufacturer, multiplied by what it has been sold, and then subtract it by leftover multiplied by salvage value. And therefore, the profit of the supply chain would be the summation of profit of retailer and profit of the supplier or manufacturer. Now let me go back to the original version when sales price was $5 from manufacturer to the retailer. Salvage value was 0 and manufacturing cost was 1. Under these circumstances, retailer orders 1 units. This is the profit for retailer, this is profit for manufacturer, and this is the total profit of the supply chain. The supply chain, in the best case, can sell 1,000 units. Can sell it for a price of $10, while the manufacturer has only spent $1 to produce it. Therefore, in the best case, supply chain can make $9,000 profit, while right now is slightly under $8,000. There is a $1,197 loss due to two things. One is lack of complete information on the actual demand. The other one, lack of coordination between supplier or manufacturer. This gap has led to a 15% less profit than the maximum possible profit. One part of it, which is lack of perfect information, requires good information system, but we can never reach to a point that be able to exactly forecast the market. Impossible. So there will be a gap over there always. However, the coordination can be fixed, can be improved. Let's go back to this problem. Go to solver. Maximize supply chain profit by changing the transfer cost that manufacturer charge the retailer, and make sure this cost is less than the retailer sales price. and make sure that this price is greater than or equal to the manufacturer cost. Okay? Solving the optimal transfer price is equal to 1, and 1 is the manufacturer cost. Under this new situation, we have made 84.74. In the previous situation, we were making 78.03. 78.03. How much improvement? This much divided by this much. That is 8.5% improvement in profit. So 8.5% of it is for coordination. The whole gap was 15.3%. Therefore, 8.5% through coordination. The rest is due to lack of perfect information. The difficulty here, when we set the transfer price equal to 1, is this. Supply chain profit goes up, but all of it goes to the retailer, and manufacturer or supplier makes no profit. There are two ways. Either they should agree to an appropriate transfer price. In this case, for example, if it is $3, the profit of supply chain will go up to this much, and that is about 6% more than original profit of supply chain. Alternatively, they can agree on risk and revenue share. For example, the sales price is $10. Manufacturer give it at price to the retailer. Salvage value is 0, but manufacturer gets 45% of revenue. 45% of $10 is $4.50, and the rest, 5.5, will go to the retailer. Therefore, the actual price of the retailer from $10 will be changed to equal to $5.5. And under this new situation, the expected profit of supply chain is this much. This is the profit equal to this much divided by original profit, and it is 9% improvement. So we discussed a base scenario. Then we explained that the best situation for the supply chain to make the maximum profit is if the transfer price is equal to manufacturer cost or supplier cost. This is the best profit they can make. The gap between these and maximum possible profit, which in this case is 6.2%, is due to lack of information. And this gap can never reach 0 because we can never turn our probabilistic word into a deterministic word. Then we discussed a buyback. We said, okay, because if we set the price equal to cost, price for retailer equal to cost for manufacturer, manufacturer makes nothing, so they may come and agree on an intermediate price, or they can share revenue. Thank you very much for attending this session.